Please, let's rise. Please sit. Good evening to you all. Would like to welcome you to the Vice-Chancellor's Occasional Lecture. The Vice-Chancellor's Occasional Lecture series was instituted to give accomplished researchers a platform to share their research work. It also provides an opportunity for researchers and students to interact with their colleagues working in similar research areas. A very warm welcome to all of you. I shall now invite the Registrar of the University of Ghana, Mrs. Emilia J. Mensah, to deliver welcome remarks and to introduce to us the chairperson for this evening's lecture. Please, a round of applause as she comes.
Thank you very much, Ms. Songsori. Vice-Chancellor, Pro-Vice-Chancellors, and other university officials from Imperial College London, members of the university community, distinguished ladies and gentlemen, a very good evening to you all, and a very warm welcome to the Vice-Chancellor's Occasional Lecture to be delivered by Professor Michael Templeton of Imperial College London. The University of Ghana has had a very engaging relationship with Imperial College London over the years, and we look forward to renewing the collaborations between various units on both sides that already exist, while we work to discover and forge ahead with new ones between our two universities in the years ahead. Ladies and gentlemen, I'm pleased to introduce the chairperson and host for this evening's lecture. Our chairperson is the first female vice-chancellor of the University of Ghana. She's a professor of linguistics and an experienced administrator with over 20 years' experience working in the higher education sector. She's a member of many prestigious societies and organizations and is a fellow of the Ghana Academy of Arts and Sciences. She's the founding president of the African Humanities Association. Ladies and gentlemen, please join me to welcome Professor Nana Bapia Amfo, Vice-Chancellor of the University of Ghana and Chairperson for this evening's lecture. Thank you.
Good evening to you all, ladies and gentlemen, and thank you for making time to attend this lecture, which will be delivered by Professor Michael Templeton of Imperial College London on the topic Research to Move Towards Sustainable Sanitation for All. Issues of sanitation are considered as basic human needs with direct impact on public health. Despite significant progress in various parts of the world, billions of people still lack access to basic sanitation services. It is evident that this need has become more of a luxury that some can't simply afford. The 2030 Agenda of the United Nations Sustainable Development Goal 6, which focuses on ensuring availability and sustainable management of water and sanitation for all, appears to be far from reach in spite of measures being instituted at the global, regional, and national levels. It is worth noting that poor sanitation has devastating ripple effects ranging from the spread of infectious diseases to the contamination of water sources. There is therefore the need to direct a bit more research attention towards engineering sustainable solutions to address this global problem. In this lecture, Professor Michael Templeton will present several ongoing international research projects that are seeking innovative engineering solutions for overcoming the barriers that currently restrict access to sustainable sanitation for all. At the University of Ghana, the Institute for Environment and Sanitation Studies is leading the charge on research on sanitation, and I believe this lecture will be an avenue to familiarize with other works across the globe and to spur our researchers on to push the boundaries in developing innovative solutions for the country and the sub-region. This lecture is an opportunity to share knowledge as well as a call to action to ensure that our collectively envisioned future where everyone, regardless of their geographic location or economic status, has access to safe and sustainable sanitation becomes a reality. With these few remarks, I shall now proceed to introduce our distinguished lecturer. Professor Michael Templeton is Professor of Public Health Engineering in the Department of Civil and Environmental Engineering at Imperial College London and the Oxfam and Water for People / Royal Academy of Engineering Research Chair in Global Sanitation Technology. He's a Fellow of the Institution of Civil Engineers and has served on strategic advisory groups and technical review panels for the World Health Organization, UK Research and Innovation, the Natural Sciences and Engineering Research Council of Canada, and the Swedish Research Council. He has conducted research and co-authored publications with partners in a number of countries, including Ethiopia, Tanzania, Ghana, Sierra Leone, Côte d'Ivoire, Senegal, Benin, India, and Nepal. He's also co-chair of Imperial College London's Global Development Hub. He holds a bachelor's degree with honors in engineering science and a PhD in civil environmental engineering, both from the University of Toronto. Professor Templeton, you're invited. Thank you.
Right, so thank you very much for that very warm introduction, and it's great for me to be back here in Ghana. This is my third time in Ghana. I always love visiting here and interacting with the people here. Thank you to your Vice-Chancellor for inviting me to give this lecture. I understand she's an expert in languages and linguistics. I'm from Canada, so I do speak two languages, English and French, but that's all. But I do joke that as an engineer, I know 4 or 5 computer languages, so I don't know if that counts also. But I recognize that not everybody here will necessarily be an engineer tonight. So this lecture is really aimed at a broader audience, okay? So it's not going to be an overly technical lecture, and I hope everybody can come away with some new information and some interesting information. As your Vice-Chancellor mentioned, I work across 12 countries currently, 7 in Africa, including Ghana, 4 in Asia, and 1 in South America. And the problems that I'll be describing tonight and the solutions that I'll be describing come from working with partners in those countries. So my research is very much about working with partners in the countries and with non-academic partners, such as non-governmental organizations, to come up with solutions. It's not about an engineer sitting in London thinking about what's best for the world. That's not how sustainable solutions come about. So I'm going to give a few examples of research that we're doing in different parts of the world to move towards the goal of sustainable sanitation for everyone. So it's a very sad truth, and it's sometimes hard when we hear the large numbers and the statistics to visualize what it means. But unfortunately, over the course of the 1 hour of this lecture, approximately 2 school buses full of children under the age of 5 years old will die. And they will die needlessly from diarrhea because they've not had access to adequate water, sanitation, and hygiene. Okay, thank you. So if you don't take anything further from the lecture, maybe this image will be one that stays with you. And if we think about it globally, the statistic is that there are about 3.6 billion people around the world who do not have access to safely managed sanitation. So that means that they don't have access to a toilet that safely isolates waste or which cannot be safely emptied and treated off-site. And the World Bank released a report only a couple of years ago which showed that actually now in the world there are more people who are not connected to sewers than who are connected to sewers. So it's a problem that's actually growing year on year. And so you've probably heard of the UN Sustainable Development Goals, and the topic of tonight is about especially number 6, which is about access to clean water and sanitation. But later on in the lecture, I'll show how really when you're improving water and sanitation, you're actually having broader impacts on other sustainable development goals. So as an engineer, quite often what we think about is, well, what is the problem that needs to be fixed? Or what is the system that doesn't work that we need to make it work better? And as I said, there's more people in the world now who are not connected to sewers than who are connected to sewers. And so if you are not connected to a sewer, it means that you have to have a system like this which works for you in order to have safely managed sanitation. So you need to have some type of containment on site, some type of safe and desirable and pleasant to use toilet. You need to have some way of emptying the waste when the toilet is full, and then you need to have some way to transport, treat, and then dispose of the waste. And unfortunately around the world, different parts of this system are not working properly. And so these images give some examples of how they might not be working. So in the first case, on the left there, you can see a toilet which has become full, and it has eventually flooded because it wasn't emptied on time. In the second picture, even if you do have access to a toilet, you might not have somebody who can safely empty it for you. So for many people in the world, it's a very dangerous and degrading job to have to empty toilets without sufficient safety equipment. And then finally, even if somebody can empty your toilet for you safely, often in many places of the world, there is no safe place to dispose and safely treat the waste. So the person who empties your toilet ends up just having to discharge it into a river or into another water body. So you can see from those 3 examples how we need to come up with solutions to make each part of this system work better. And they're not all engineering solutions. This is a very interdisciplinary problem. There's a lot of social science and education and governance and finance involved in solving this problem. But engineering definitely is at the heart of some of these technical challenges. So sanitation is it can be kind of a depressing topic. So I want this to be an optimistic lecture though. So I'm first going to talk about an example of some research which is actually a success story, which is an improved type of toilet, of affordable toilet that seems to be working very well in many countries in the world. So the idea is that we've, with our partners, created something called a tiger toilet, which is not a toilet for tigers. It is a toilet that uses tiger worms, which are a type of composting worm, very common type of worm. They're found almost everywhere in the world, although in Africa there's a very similar worm called the African night crawler. And the great thing about these worms is that they're sort of like a wastewater treatment plant all on their own. They're very good at degrading waste, treating waste, and turning it into very safe products. So they make compost and they make the liquid cleaner. So the idea that we had from this grant was basically to adapt a basic pit latrine design, which many people can afford and are currently using, to achieve composting of the human waste by tiger worms. So basically the idea is put some tiger worms in the container, as you can see there in the image, and the user doesn't even know necessarily that there are worms treating the waste, but the worms are going to treat the waste, make it safe, and actually they reduce the filling rate of the toilet because they convert most of the waste into CO2, which they breathe, and then they also produce compost at a slow rate. And ideally we wanted this to work so that also it was a more pleasant experience for people, so that there were fewer smells, for example, and that when you did have to empty this latrine, it would be a much safer experience. So this was a highly interdisciplinary project with many academic and non-academic partners, and it involved a lot of community engagement from the beginning. So right from the beginning, it was about talking to people who would be the end users of this toilet. What did they like about the idea? What did they not like about the idea? And then coming up with a technical solution that was affordable and desirable and sustainable for those people. And I've acknowledged some people here who worked for some of the other institutions that were involved in the project, which was funded originally by the Bill and Melinda Gates Foundation. And really, it was a really good example of what I like to call the eye-to-eye concept. So, and I think if there are any engineers in the audience, it's something that maybe you think about a lot, is if you have a very good idea, how do you translate that idea into impact? And in the case of the tiger worm toilet, there were two sort of sections of time. There was a stage in the first 2 years where we came up with lots of different ideas with partners and stakeholders. We then did some really robust testing in the lab and at pilot scale. And then we also at the same time did community engagement, and we started with this work in India, but it's now being used in about 12 countries around the world. And then once you are sure that you have an idea that works and that people are willing to buy and to support, we then formed a joint venture with some sanitation entrepreneurs in India who were then able to scale up the idea and make it a viable business. And at that stage, they presented us with other opportunities for research to actually go out into the field and see how the design was working and talk to the users and find out what they like, what they don't like about it. And ultimately now, there are several thousand of these being used around the world, and we want to share good practice and also scale up the idea so that more people can have access to it. And I know there's actually a company here in Ghana who have taken up the idea and who are making tiger worm toilets in parts of Ghana also. And a lot of academic research stops at the top part of this slide. And I think something that Imperial in particular is really good at is not just stopping with the idea, but trying to go to the next stage of working with partners and making sure you can achieve impact in the real world. So to go through the steps, so initially you have to start with some experimentation and some hard science. And this is what universities are good at, is doing experiments. So we basically set up an experiment where we had two types of conditions, one that had the tiger worms, the other one that didn't have the tiger worms, and we fed it with human waste in a controlled experiment. And this is some very crude data. I promise that there won't be too much mathematics or data in this presentation. But basically what we found was that the toilet that had the worms filled up only about 1/3 of the rate compared to the toilet that didn't have the worms, with everything else being equal. So this gave us the initial idea in the lab that actually this isn't just a good idea, it actually kind of works. And so then once we finished the lab work, we went to pilot scale. So we created some toilets that actually hundreds of people could use. This was actually on a visitor center of an eco park. And so then we could measure how it worked when lots of people were using the toilets and flushing water through it under realistic conditions. And that also worked very well. And at the same time, as we were doing the prototypes, we spent a lot of time out in India talking to the people who would be the end users or the market for the technology. So asking them, does this idea make sense to you? And part of the reason we started in India is that they already had a culture of composting waste there, livestock waste. So it kind of made sense to them to use worms for this purpose. And by talking to them, we also figured out how much they could afford, how much they were willing to pay for it, and what would be their concerns with the technology. So then several thousand of these were installed, and once they were installed, they were used for many years, and it allowed us an opportunity to go back and to see how the technology was working. And as engineers, we always like to model things to try to understand how it's working. And we really wanted to understand, well, how quickly is this toilet filling up? Is it really slower than a normal latrine? So we went back to some toilets which were built 7 or 10 years ago, and we took the lid off and we observed, were the worms still healthy? Were they still producing compost? Were they treating the water? And how quickly were they filling up? And it was really encouraging that even after many years, without any maintenance, the worms were still very healthy population and active, and the toilets were not filling up, except with compost material. And I even had a student who was quite good with gadgets and technology, and he wanted to have visual confirmation that the worms were still working. So what he did was he put some red light cameras into some of the chambers where the waste was introduced, and he actually was able to record videos to show that the worms, after many years, were still active and were still doing the job of treating the waste. I won't show the video though, because I want you to enjoy your dinner later on this evening. But trust me, it works. And it works very quickly too, about 30 or 40 minutes, and the worms have eaten all their food. And during the pandemic, I spent a lot of time at home. I think I was at home for about 18 months in a row. And some people during COVID, they learned to play the piano or they learned a different language. In my case, what I decided I would do is create a sanitation association. So I contacted as many people around the world who I knew who were building these tiger worm toilets. And we formed this association and had online meetings to share what was going on, what were the good practices and the bad practices, and what are the opportunities to scale up this technology so that it reaches, the millions or even the billions of people in the world who could use it. So if you're interested in knowing more about the technology, this website has a lot of useful information, including a design manual. So if you want to go home after this lecture and build your own tiger worm toilet in your garden, you can find all the information about how to do that on the webpage. So how widespread is this today? This idea came about in about 2010, so how far have we come since then? It's now used in at least 9 countries. I think it's more like 12 or 13. We estimate there are over 200,000 people being served, and this is actually increasing very rapidly because a lot of companies are sprouting up and they're starting businesses using the information that's been shared and adapting the technology for their own conditions. And as I mentioned, there's at least one company, probably more, in Ghana who are selling this technology. So we estimate there's about 57 tons of waste being treated per day, approximately. And the charity Oxfam promoted this technology, and they estimated that over the course of 5 years, the cost of this toilet is about 90% less than a normal pit latrine, because you don't have to empty this toilet. it's not filling up as quickly as a normal latrine, which you would have to empty every few years. Okay, so that's, I think, a sort of I use that as an example of a success story and how it is possible to go from an idea through to achieving big impact, as long as you work with partners and you take a good approach of working with the end users of the technology right from the beginning. Another theme that I'd like to quickly discuss is about the idea that sanitation is more and more today being thought of as a service instead of a technology. Okay? So as engineers, we like to think we can solve all problems by just building a technology. We'll build something and it will fix all the problems. But increasingly, people are starting to think that we have to think of sanitation as more of a service. You're supporting people. You're not just giving them a technology or selling them a technology. And so a trend around the world is what's called container-based sanitation. And I'm here in Ghana this week because I'm part of a large research project involving the University of Ghana. And we're thinking about how do you do sanitation, especially in places where there's flooding, which I know is a problem in many parts of Ghana. And especially for the urban poor who don't necessarily own the land that they live on, they tend to be very susceptible also to flooding. So you can't really do a tiger worm toilet in those situations because you can't dig into the ground to make the technology. So instead, the model that has been used in about 10 countries around the world is a service model, which is instead of selling someone a technology, you provide a sanitation service. So you provide a toilet with a container inside it, and you would regularly empty that toilet, maybe on a weekly basis. And it's an excellent technical idea because it's above ground, so if there's flooding, the toilet is not going to be flooded as much. It's also a portable toilet. And also the company executes all parts of that sanitation chain that I showed on an earlier lecture. So they provide the container, they take the container away, they transport it safely back to their headquarters, they treat the waste, and they produce some kind of useful product. It could be like a soil enhancer for selling as a fertilizer, or it could be to generate biogas energy. And then they provide the container back to the customer. So it works as a circular business model. And again, I know in Ghana, there's one of the best companies in the world who are doing this called Clean Team in Kumasi. And I'm hoping over the course of this project that I'll be able to hopefully reach out to them and learn from them about what works. Another topic that we're thinking about is how do we recover value from the latrine contents? So what's the best value, the most monetary, best return that we can get when we empty the contents of latrines? And something we're especially interested in and doing research with colleagues in Rwanda and Uganda currently is this idea of what's called pyrolysis, which is about raising the temperature of the waste and being able to produce oil and gas or a type of solid fuel, briquette, or char material from the pyrolysis of the waste. So this is not a new idea. This is a technology that's been used for sewage sludge treatment for many years, but it's never been used in the context of pit latrines in low-income settings. So I think that's something that we're seeing as being very promising, and there are businesses that are starting to try this in parts of Africa as a business model. And a final sort of topic that I'll mention as a research priority is the fact that there's a lot of toilets being constructed around the world to meet the Sustainable Development Goal for access to toilets. But there isn't always careful enough consideration of the groundwater near the toilet. And so we've done some modeling to look at how can we minimize chemical pollution of groundwater, especially nitrate, which can come from the bottom of latrines and make its way into drinking water. So again, I think that's a research topic that requires more work and where universities can do the sort of sophisticated modeling that's needed to answer this challenge. So your Vice-Chancellor mentioned that I've recently started a research chair, which is with Oxfam, who some of you might know, the UK-based charity, but also Water for People, who are an American charity, and the Royal Academy of Engineering in the UK. And we decided we would try to address several of the technical challenges that these charities have identified in the field when it comes to sanitation. So I won't go through it in detail, but basically there are 4 projects, and they're all looking at different parts of this sanitation chain. So we want to look at how can we recover value from the waste. Oxfam are also very interested in whether you could have a very rapidly deployable septic tank, so something that you could ship around the world and somebody could assemble it at home very quickly and easily without any skills or tools in sort of 6 or 8 hours, sort of like how you would assemble furniture in your home. So these are all technologies that I think could really be game changers and could solve technical problems that are part of the sanitation problem, which is not purely about education and social science, which is sometimes what people think about sanitation. And finally, the last few slides are about the fact that when we think about the Sustainable Development Goals, we need to remember that they are all linked together. And I don't think enough people really think about this. And even if you're not an engineer, this is probably something that you can apply to your own work if you're working in medicine or natural sciences or social sciences. So, for example, I'm looking at SDG 6 with clean water and sanitation. But if I install toilets in a school, for example, that's going to improve quality education in that school. So that's SDG 4. And a lot of girls, unfortunately, around the world drop out of school when they reach the age of menstruation because there are not sufficient facilities in schools. So it's also related to SDG 5 about gender equality. So I guess I would challenge all of you, whatever topic you're working on, to think about which of these SDGs you're actually addressing. And I would bet you that it's probably at least 4 or 5 that you can think of. And it's important to think of that because then you can design your work to optimize or to maximize the impact towards each of those SDGs instead of just focusing on one of them. So the example that really made this very clear to me was this photograph that my PhD student Laura showed me. So she went to Ethiopia where she was doing a project on sanitation in schools, and she showed me this photograph and she said, "Mike, how old do you think that little girl is in the center of the photo?" And I looked at it and I thought maybe she was 6 or 7 years old, perhaps, something like that. But it turns out I think she's actually 12 or 13 years old, that little girl. And the reason why she's so small is because she's got a lot of intestinal worms because the sanitation conditions are so poor in her school. So it just shows that sanitation is not just about sanitation. It's about child health, and it's about improving education conditions for these kids. And it's about really affecting the future generations of the kids who, this little girl will probably have lifelong health problems because of the conditions in her school when she was a little girl. And one example of a disease we're working on it's a bit hard to say, but it's called schistosomiasis, which is a disease that occurs in some parts of Ghana. You might have heard of it before. But it's a disease that people in international development call it a wicked problem. So a wicked problem is one that's been around for thousands of years and we haven't been able to really stop it. And the way the disease is spread is that people who have the worms in their body, the worms lay eggs, and the eggs exit our body if we don't have a proper toilet. They exit our body in urine or feces, and they go out into the environment, where they infect a snail, and then the snail actually releases a parasite which infects other people. And this isn't a drinking water parasite. This is a parasite that even if you come in contact with the water for a few seconds, you can get the disease. And you only have to be infected by 2 of these parasites to develop the worms in your body. So it's an extremely efficient cycle, disease cycle, which is why it's a wicked problem. It's very hard to stop. And I put a picture of the ancient Egyptians and Napoleon Bonaparte on the slide because people have actually looked at mummies of ancient Egyptians and they found mummified worms. So we know that the ancient Egyptians had schistosomiasis from the Nile River. And when Napoleon, the French emperor, invaded Egypt in the 1800s, early 1800s, a lot of the French army got schistosomiasis. So it's something that throughout history people have been burdened by it. And the World Health Organization really wants to eliminate this disease. So they want there to be 0 cases at some point in the near future. And the current estimate is there are about 200 million people who are infected or affected by this disease, and about 90% of those are in sub-Saharan Africa. There's also a little bit in Southeast Asia and in Brazil and South America. And for a long time, the World Health Organization's strategy was, let's give people drugs. So let's try to kill the worms that are infecting these people with drugs. But unfortunately, the drug that's available is not a vaccine. It's only a deworming drug. So you can take the drug and you'll be fine for a few weeks, but if you still don't have a proper toilet or access to clean water, you're going to get reinfected very quickly. And studies have shown where the pharmaceutical companies have done massive drug delivery programs, and then they've returned to those villages 9 months later, and it was almost as if no drug delivery program had taken place because the water and sanitation conditions had not improved. So the role for water and sanitation really is if you did have access to a toilet, this would prevent the parasite from reaching the water and infecting the snails, and it would break the disease transmission. And some people have also said maybe we should try to kill the snails that are the intermediate host of the disease. And that's also possible, although it comes with environmental concerns. And then finally, you could also provide clean water, which means that people don't have to have contact with the contaminated water source. So my point of this slide is just to show that, again, if you're working on one small part of a problem, if you work with partners who are working on other parts of the problem, you can actually address that problem more holistically. And so we had a grant called the WISER project, which it stood for Water Infrastructure for Schistosomiasis Endemic Regions, and it involved partners in Tanzania, Ethiopia, and the UK, and it was very interdisciplinary. So there were engineers, but there were also biologists, social scientists, and we actually even had an actor, a Hollywood actor who was involved, because he worked as part of a charity which did theater-based behavior change and education campaigns related to this disease. And Imperial currently, the university where I work, is really trying to encourage more interdisciplinary large projects like this. And so we've founded in 2021 the Global Development Hub, which is all about trying to encourage more partnerships with universities like the University of Ghana so that we can work together on solutions for all of the SDGs. So not just water and sanitation, but achieving all of the SDGs. And so this is a cross-university strategy, and I'm one of the co-chairs, and my colleague Sarah Fiddler, who's an expert in HIV and communicable diseases, is the other co-chair. So we have one engineer and one medic who are leading this initiative. And so it's been really great to use this initiative to partner with institutions like the University of Ghana, on a range of different projects to address SDGs. So my final slide, my take-home messages, so the things that hopefully I hope you can remember from the lecture. First of all is that we should be optimistic. You know, sometimes when we talk about sanitation and we hear these big numbers, we can be very pessimistic. But really, if you do robust research, that actually can lead to practical sanitation solutions if you think about taking an idea through to impact. Also, that progress towards the SDGs is possible with partnership, though. So academics, I think, need to work differently than we have in the past, and not just stay in the university, but work internationally and work across disciplines and work with people from outside of academia, and most importantly, work with communities and the end users of the solutions. And finally, I hope that some of the things that I've talked about are interesting and exciting for you. And I think sanitation is an exciting area to work in because the impact potential is so huge from sanitation. So some acknowledgements to finish my lecture. I'd like to say a huge thank you again to the Vice-Chancellor of the University of Ghana for inviting me to give this talk, and also my research funders, who I've listed there on the slide. I'd also like to acknowledge my brilliant collaborators across the world, including Dr. Jacob Doku Tete. Is he here tonight, Jacob? Somewhere? Jacob, who's from the University of Ghana, who's shown there on the top right of the slide, who's worked with me on projects to do with water supply in Accra. And finally, I'd also like to acknowledge my exceptional research team, because professors are not really the ones who do the research. It's really the students and the postdocs and the researchers who do it. So I'd like to acknowledge their contributions as well. And finally, thank you for coming and for listening, and I hope it's been good food for thought tonight. Thank you very much.
So thank you very much, Professor Templeton, for that very insightful lecture. I'm not sure about you, but I never thought that we could use worms in this way as he's described. And so, Professor Templeton, even though we did not have a slot for questions and comments, would like to allow the audience to interact with you through questions and comments. So it's time for questions. I think that what we'll do is to take 3 at a time. He would answer, and then we take the next batch. So there's a microphone going round. If you have a question, please tell us your name. If you're a student, your department and level. If you are a faculty member, do let us know which department you are coming from. Any questions? Okay, so we have one hand up over there. Yeah.
Okay, thank you. Thank you. Naya James from Department of Biomedical Engineering. Okay, so my question is, with regard to the worms, the tiger worms, what you spoke about was majorly the positive aspects of the worms. And in our settings, I'd like to know if there are some, should I say, disadvantages that come across with using the worms. So what are some of the possible side effects of applying the worms in our situation? Thank you. As in, you spoke about the advantages, right, of the worms. So what are some of the disadvantages? Thank you.
So we'll take a second question.
My name is Chris Gordon. I'm with the Institute for Environment and Sanitation Studies. I have quite a lot of stuff that I'd like you to comment on. Can you hear me? No. Okay, let me come to you. You're the big guy. So the first thing, I want to know your position on the whole mindset attitude, because the role of culture is very important. The second is your view on climate change as an amplifier. I'm probably the only person here who has had schistosomiasis. Yeah. It's not fun. I used to weigh 55 kilos. Now you can see I'm cured. Okay, nice. I would also like you to comment on sanitation, refugees, and conflict vis-a-vis the technology that you're putting forward. And the last thing is the problems of not understanding the system, in that you have your worms and somebody decides to spray with a pesticide. Yeah, thank you.
Okay, I'll try and remember all of those. So the first question was about what are the disadvantages of using the tiger worms. So I'll be the first person to say that no technology is going to work everywhere, and there are some conditions that are more appropriate for some technologies than others. And so, for example, I wouldn't use a tiger worm toilet in an area that had a high groundwater level or was prone to flooding. Because if the worms get too much water, they will drown and they'll stop working. So they're not a suitable solution really for flooding zones unless you were to use them above ground. It's not really a disadvantage, but something you have to be careful with is you don't put a lot of toxic chemicals down in the toilet. So we found sometimes that people use cleaning agents like really strong chlorine, and that can kill the worms sometimes. But you can get around that problem by using sort of worm-friendly toilet cleaners, and requires a little bit of user education, but it's a problem that can be sorted out. Other than that, though, I mean, I think it's very important if you're going to do tiger worm toilets that you do consult with the users. You know, if the users don't like the idea of having worms somewhere down below their toilet, they're not going to want to use it. So I would say it's very important that you culturally sensitize people also to using the toilet. So the second set of questions. So the first one was about culture and how important culture is. And I completely agree with that. And as I said in the lecture, as an engineer, I think you have to start with listening and understanding what are people's understanding, what are their values, what do they understand about public health, about why do they want a toilet. It might not even be about health, it might be about dignity or safety or other reasons. So I completely agree that culture and gaining a perspective on the understanding of the users is very, very important. And it should inform engineering, I think, instead of the other way around. The second question was about climate, I think. So climate, and part of what we're doing in the current collaboration that I'm here for this week with the University of Ghana is on climate adaptation and climate resilient sanitation. And there are big technical questions. So if you have a flooding zone, or if you're going to have more flooding in the future, you probably need to think about above ground toilets, or maybe contained toilets, as opposed to conventional pit latrines. And on the other side of the coin, we could face a future where we have less water. So if you have a drought, that's also a problem for a lot of sanitation technologies. The tiger worms, for example, they require a little bit of water to survive. But also a lot of the technologies that people use, they rely on water for flushing the toilet. So I think it's an area where we need to think into the future about what are the water conditions and the heat conditions going to be in the future, and maybe think about redesigning our sanitation technologies to be effective in those conditions. There was a comment on schistosomiasis, but I think that was a comment. There was a question on, what was the last one? Refugees, right. Refugees, yeah. So one of the charities I work with is Oxfam, who they have now essentially become solely about refugees and humanitarian situations, emergencies. And the problem in humanitarian emergencies is that quite often you need to install infrastructure very quickly. You need to do it in very difficult situations. And it's also not clear how long a refugee camp is going to be there. So I think what Oxfam have found is that you might put in a temporary sanitation solution, which might be intended to last for a year or two, but then that camp might still be there 20 years from now. So I think there's a lot of thinking that's required to maybe think about how do we make sanitation refugee camps longer lasting, maybe thinking a bit further into the future. But at the same time, I think there's also a need for more rapidly deployable solutions which can be installed as quickly as possible in these very, very difficult conditions. So like that septic tank, flat pack septic tank idea that I mentioned. And then there was one final question also. For the tiger worm toilets, yeah. So it was about, are they affected by chemicals? And they're pretty robust to most chemicals, but if you put a lot of bleach down the toilet, they don't like that very much. So, yeah. Yeah. Oh, okay.
Do you have any more questions, comments?
Thank you very much, Mike. That was very exciting. I didn't get the part about the carbon dioxide. How did you say that was handled? Carbon dioxide. You said there will be production of carbon dioxide. Carbon dioxide, yeah. Oh, you said carbon. Yeah. Oh, okay. I thought you said the. Yes. So I thought you said that they will, you know, as worms they will breathe and produce carbon dioxide. And how do you ensure that that doesn't suffocate them? Because yeah.
So the question was about how the worms, because they're organisms like you and me, they breathe CO2, they exhale CO2. But because the toilet is an open system, it's a very small amount of CO2 that they're producing because they're quite small, the worms, and it tends to ventilate out of the latrine anyway, so it doesn't tend to stay in the latrine and suffocate them. But it's an interesting question because something we're looking at currently is whether you could actually use carbon financing to fund tiger worm toilets. Because if you have a normal pit latrine, it's emitting methane, CH4, which is a very bad greenhouse gas. Whereas the tiger worms are an aerobic process. They're breathing oxygen, they're releasing CO2. So actually they're having much less of a greenhouse gas emission compared to a pit latrine. And these days, people will actually pay you for carbon credits if you're reducing methane emissions. So we're really interested in whether you could start a tiger worm toilet business which is funded entirely from carbon credits. You know, somebody on the other side of the world says, I want to pay you 1 million CDs to build, I don't know, 100 tiger worm toilets, and by doing so, I'm taking all of this carbon out of the atmosphere, which I think is a trend that will be interesting in the future.
Okay.
Thank you very much for the insightful lecture. My name is Peace Amwate. I'm a civil engineer with the Department of Agricultural Engineering. Yes, my question is, how long does it take for the worms to die out? Do you have to replenish them? And then my second question is, in these days where we find there are traces of antidepressants, hormones, contraceptives and things in our waste system, how does it impact on the worms? And in the long term, thinking about the circular economy, where we can make compost from this waste and use in our soil over time, what would it look like? Thank you.
Okay, so 3 good questions there. So the first one was about, how long do the worms live? So the worms, an average tiger worm lives between about 2 and 5 years, something like that. But the thing is that they're always reproducing in the latrine. And as long as there's a steady supply of waste into the latrine, the population will continue to grow until it reaches a steady state. So the idea behind tiger worm toilets is that you have to add some worms initially. So the research we did showed that you need about 2 kilograms of worms for a household of about 10 people, let's say. But then after that, the population sustains itself. So some of them are dying after 2 to 5 years, but others are reproducing. And you sort of end up with the same number of worms in the latrine over time. That was one of the really good ideas about the technology, is that you don't have to add any more worms after it starts. There was a question about sort of pharmaceuticals and antibiotics in our waste. They don't seem to affect the worms. I think the concentrations are probably low enough that they don't affect the worms. And actually, some of the research has shown that the worms partially degrade the antibiotics. So as they're transforming the waste into compost, they're also affecting the chemical structure of the pharmaceuticals to a degree. So that's sort of a nice, natural way to treat these contaminants also. Then the third question is about circular economy, and could we use the compost for some beneficial purposes? The original idea of the tiger worm toilet was to create a toilet that wouldn't fill up very quickly. So while it produces compost, it's sort of a byproduct. It's not something that we are trying to produce. But over time, you will have a lot of compost in a toilet. And research has shown that it does have good nutrients, so it can be useful as a soil enhancer, potentially to improve soil quality. The one thing I'm still worried about, though, is helminths, like ascaris and other types of pathogens, which produce these eggs, helminth eggs, which, although the worms kill almost all the bacteria and the viruses, I don't think they're very good at killing hookworm eggs, for example. So in that case, I would be very worried about recommending that people use the compost certainly for food crops, maybe for other types of agriculture, but probably not for food crops, I think, yeah. But our purpose was to create a toilet that doesn't fill up. It wasn't to create compost, really. That was sort of a secondary consideration. Okay?
So we'll take two questions from this side, and then we'll close. Thank you.
Okay, hi, thank you. Please, my name is Crystal. I am a level 300 student, biomedical engineering. So I have 2 questions. The first question is, how or what measures are put in place to make sure that the worms don't just like burrow out of the toilets? I don't know. Maybe I didn't hear that part of the presentation, but I'd really like to know. And then, is there like an open door for improvement based on the feedback that you're getting today, or that's just it? And please, how do you plan on like developing this maybe for commercial use later on? Thank you.
So the first question is, I think it was, how do you make sure the worms don't just leave the toilet, right? Was that the question? Yeah. So this was a concern I had when we had the initial idea. But actually, worms tend to stay where their food source is. So as long as the toilet keeps being used, they don't go anywhere else. Also, the worms that we're using are native worms. They're from that location. So I'm not saying that you have to ship worms from the UK to Ghana. You would use Ghanaian worms to do the latrine. So even if they did leave the toilet, like into the soil, it's not like it's an invasive species or something that's going to cause problems in the ecosystem, because the worms came from the soil in the first place, if that makes sense. Yeah. Second question was about what have been some of the changes or based on user feedback. And well, one example is the thing with the cleaning agents, which was something which we only found out when users started using it, and the latrines that weren't working as well, it was because we found out they were using harsh chemicals to clean the toilet. So that didn't really lead to a redesign of the toilet, but it meant that we had to have sort of clearer instructions for people about what types of chemicals are harmful and which ones are okay to use for cleaning the toilet. But I think there's lots of opportunities to further develop the design and to adapt it to your own country or your own materials, your own situation. So for example, one thing is we used to have a sand layer underneath the worms, which we thought was important for filtering the water as it went down through the worms and out the bottom of the toilet. But we found that sand layer quite often clogged very quickly with solids. And so we decided the designs nowadays, we don't use that sand layer. We don't find that it's necessary. The worms can treat the liquid part on their own, and the toilet doesn't clog up as quickly. So there are definitely optimizations that can be done. And as I said in the presentation, our philosophy is to really share good information. So we intentionally did not claim intellectual property on this. It was all about publishing as much information as we can, finding out what works in different places, and encouraging businesses around the world to create their own design. And that's happened in about 10 or 11 countries. Because I think that's how you achieve scale around the world. You know, it's not by sort of protecting IP and saying, I'm the only one who can sell a tiger worm toilet. It's about getting more people involved and making the design better and, creating business conditions that are going to work for you in your country. Commercially, it is something that's being sold by companies around the world. So it is something that's commercially viable. A lot of the people who are selling tiger worm toilets, they previously were masons or people who just made pit latrines, who have sort of added this as another product that they can offer to people.
So a round of applause as he takes his seat. I'm sure you all agree with me that this has been a really insightful lecture. If you are a non-scientist like me, today we've heard that the worms breathe in oxygen and breathe out carbon dioxide, like you and I. So if you didn't hear anything at all, you can take that with you this evening. Would like to invite the Ghana Dance Ensemble to give us a short interlude before we take the chairperson's closing remarks. Thank you very much, Ghana Dance Ensemble. Thank you very much for the brief interlude. The dance that they just performed is the Damba dance, and this is a royal dance from northern Ghana. It's performed for special visitors of the King of Dagbon and for his personal entertainment. So this is a special performance to welcome you, Professor Michael Templeton, to the University of Ghana. Please let's appreciate the Ghana Dance Ensemble one more time. Thank you very much. We'd now like to invite our chairperson, our Vice-Chancellor, Professor Nana Abba Apia Amfo, to deliver her closing remarks. Please, let's welcome her.
Good evening to you once again. And Professor Michael Templeton, I would like to thank you for delivering this insightful, down-to-earth lecture on research to move towards sustainable sanitation for all. This evening, I have learned about the importance of toilets. And I didn't realize that someone can dedicate his life to learning about toilets from all parts of the world and working towards improving sanitation through work on these toilets. And in fact, Professor Templeton demonstrates research that provides solutions. And so he demonstrated the importance of the interdisciplinary work. If indeed we want our research to provide solutions, best way is to work together from across disciplines. Engineers working together with social scientists, health scientists, humanists, and really across the board, from different disciplines, from different geographical areas, and then even for me, more importantly, academics working together with non-academics. We saw when he gave the example, I think one of your teams has a star, right? What does the person do? Is it an artist? Yeah. So it's important for us to connect with our communities. We cannot keep talking to ourselves, just working among ourselves as academic, and expect that the research that we do would actually impact the societies. And this really, Prof. Templeton, this aligns with what the University of Ghana is seeking to do more of. I mentioned to you earlier on that we're going to launch our new research strategy next month, and one of the 5 strategic priorities is engagement and partnerships. And by that, we recognize the importance of building strong partnerships with industries, governments, and communities. And so not just working among ourselves as academics, because these relationships, when grounded in mutual respect, will catalyze innovation, reinvigorate our practices, and amplify our influence as academics. We also saw a demonstration of the interconnectedness of the SDGs. Right, so working towards attaining one SDG, you invariably, as a side product, also contribute to the attainment of others. And so through his lecture, we saw how at least the SDGs 3, 4, and 6 are interconnected, even SDG 7 as well. And that sent me to the value of the pit latrine contents. Did anybody ever think that there will be any value for pit latrine contents. But we see what we can get out of it: oil, gas, fuel, and that also reminded me of the inaugural lecture that we had last week, where we saw research on plastic waste being turned into fuel for our use. And that really works towards affordable and clean energy, which is the SDG 7. Finally, I see an alignment of the goals of University of Ghana and Imperial College. Professor Templeton talked about having an idea, starting from an idea and moving it right to impact. Again, this is what University of Ghana seeks to do more. And so our new vision is to achieve global impact. And we want to do this through innovative research, such as the one that he is doing with partners here and across the world, and using a technology-driven approach and people-centered approach. Professor Gordon was trying to draw our attention to the fact that we cannot sit in our comfort zones as engineers, scientists, and create solutions for communities and think that these solutions will work if we do not get their buy-in, if we do not contact them, engage them, if we do not put cultural considerations in place. And so, working with all of these, we hope, Professor Templeton actually gives us hope that we should not despair. We can actually provide solutions for this world. And not too long ago, Professor Templeton, I heard a lecture which did not give hope at all with regard to the attainment of the SDGs. And in fact, when you see all the things that are going around, as I was beginning to lose hope. But this evening, you've lifted our hopes up that we cannot really give up, but we should all work together as scientists, as social scientists, as humanists, as academics, as non-academics, as community members towards better communities and a better world. Thank you, Professor Templeton, for honoring our invitation and for delivering such a brilliant lecture. Let's all have a good evening.
Thank you very much, our Vice-Chancellor, for summarizing Professor Templeton's presentation very nicely. I'm sure that even for those of us who are non-scientists, we're able to appreciate the things that he talked about, and we are going away with a lot of food for thought. And happy that the University of Ghana is partnering with Imperial College on a number of issues. Just before this evening's program, we signed a memorandum of understanding for continued partnership with Imperial College. So we look forward to having a lot of our researchers and students also being part of the big things that are happening outside the University of Ghana. Please, if you are happy to be here like me, let's please appreciate Professor Templeton one more time. And also to the Vice-Chancellor for hosting this very important discussion. So we've come to the end of this evening's occasional lecture. As you leave the hall this evening, there's some light refreshments for you. We'll kindly ask our students to exit through the door on my right-hand side, and pick up a pack before you leave. Students and staff, please use that door. Senior members, please use the door on my left as you exit to pick up your pack before you go. So kindly, thank you very much. We wish all of you a good evening. Please rise for the university anthem.